Hello dear children, welcome to Relations and Functions. In the last classes we have learned relation, types of relation, and based on the concept of relations we have completed exercise 1.1 also. In the today's class we are going to learn very interesting and important concept, that is function, and special types of relations we are going to call as a functions. That special types of relations we are going to learn in the today's class. And let me start the today's class with functions. This is very important and interesting concept, and this one we are calling as heart of the calculus. And so I told you the special types of relation is going to call as a function. To define a relation we need Cartesian product of two sets. To define a Cartesian product of two sets we need two sets, two non-empty sets. So I'll consider now two non-empty sets. Set A, that is having elements 1, 2, 3, and again I'll consider set B, that is having elements A, B, C, and I'm going to write now Cartesian product of two sets as A cross B. A cross B is the Cartesian product of two sets. So A cross B is having elements 1 comma A, then 1 comma B, then next 1 comma C, and next elements are coming 2 comma A, 2 comma B, and then 2 comma C, and next ordered pair is coming 3 comma A, 3 comma B, and next ordered pair coming as 3 comma C. And this is what Cartesian product of two sets. I told you any subset of A cross B is called as a relation, and we are going to learn special types of relation, that is what functions. So which types of special relations we are going to call as functions, we'll see. A relation F. Okay, relation you can define with R, or I am calling this one as F because this relation is function. A relation F from set A to set B. Set A to set B is called a function. If every element, see, if every element of set A has one and only one image, in set B, one and only one image in set B. Every relation F from set A to set B is called a function if every element of set A. So here two conditions will come. The first condition is every element should have image, and the second condition is they should have only one image in set B. So that type of relations we are going to call as a functions. So I'll consider now subset of A cross B, that is relation, and then we'll think that relation is function or not. With arrow diagram I will consider the relation. So first I'll consider a relation with the arrow diagram. Set A, this is having elements 1, 2, 3, and set B, this is having element A, B, C. And what is the condition here? Every element of set A should have one and only one image in set B. So I am going to consider the relation now here. 1 is related to A, 2 is related to B, 3 is related to C. And this is a relation from A to B because this is subset of A cross B, because A cross, this relation is having element 1 comma A, 2 comma B, 3 comma C. That is set of A cross B. So this is a relation, and now we'll think this relation is function or not. We know that if ordered pair x comma y, this is present in the function. If this ordered pair belongs to the function, here y is called image of x. Y is called image of x, and x is called pre-image of y. Y is image of x and x is pre-image of y. And this one we are writing f of x. This is equals to what here? Y. And I will think this relation is function or not. What is the first condition here? Every element of set A has one and only one image. Every element they should going to map, right? So 1 is going to map with A, 2 is going to map with B, 3 is also going to map with C. So each and every element of A is having image, and next condition is they should have one and only one image. And now think, one is having only one image. Yes, that is correct. One is related to only one element, means one is having only one image, and 2 is related to only one element, that is nothing but 2 is having only one image, and 3 is related to C, its meaning 3 is having only one image. So this relation we can call it as a function, because this satisfies the definition of function, means every element of set A is having one and only one image in the set B, means ordered pair 1 comma A, this is present in the relation, its meaning we can write f of 1, this is equals to A is image of 1, 1 is pre-image of A, f of 1 is A, and f of 2, and that is what here B, and f of 3, that is C. All the elements of set A, all the elements means every element of set A is having only one image, they are having one image in set B. So this type of relation we are going to call as a function. So this relation is function. So now I'll consider another relation, and I will think, is this a function or not? So now I'll consider another relation, that is from set A to set B. Set A is having element 1, 2, 3. Set B is having element A, B, C. And here 1 is related to A. 2 is also related to A, and 3 is related to element B. And now we'll think, is this relation is a function? Now think, the first condition, every element should have image. So 1 is going to map, then 1 is having image. 2 is going to map, yes, 2 is also having image. 3 is going to map, yes, 3 is also having image. Each and every element of set A is having image. And now think, and that all should have only one image. So A is having one image, yes, right. 1 is having image A, and again 2 is also having image, that is correct. 2 is also having image, that is A, and 3 is also having image, F. 3 is also having image, that is B. Each and every element of set A is having image, and that too single image. This is possible that two elements can have same image, or else all the elements of set A can have the same image, that is not a problem, but every element should have only one image. So 1 is having only one image, that is correct. 2 is also having one image, yes, that is also correct. 3 is also having image, yes, that is correct, and that too 3 is having only one image. And here any element left in the codomain, that does not matter to us, because every element in set A should have image, means every element of the set A should going to map with some elements of set B. So this type of relation we are going to call as a function. So now I'll consider now another example. Consider another relation from set A to set B. So set A is having element A, 1, 2, 3, and set B is having element A, B, C, and 1 related to A, 2 related to B. So this is a relation from A to B. Yes, this is a relation from set A to set B, because 1 comma A, 2 comma B, that is subset of what here? A cross B. So this is a relation. And now think, is this relation is a function or not? So what is the condition of function here? The condition of function is every element of the set A has one and only one image in B. Every element of set A should have image, and that to what here? Single image. That to what? Single image in the set B. So 1 is having image, that is correct. 2 is also having image, that is correct. And now think, 3 is having any image? No, 3 is not going to map with any element of the set B, or 3 is not related to any element of the set B. So this is not a function. This is function, and this is not a function, because 3 is not having any image. 3 is not having any image. So this is not a function. Hope you are all understanding this one. I'll consider now another relation, the relation from set A to set B. Set A is having element 1, 2, 3, and set B is having element A, B, C. And I'll consider now 1 is related to A, 1 is also related to B, 2 is related to B, 3 is related to B, and this is a relation from set A to set B, because this relation is having element 1 comma A, 1 comma B, 2 comma B, and 3 comma C. And now we'll think this relation is function or not. So what is the definition of function? Every element of set A has one and only one image in set B. So every element is going to map. Yes, every element is going to map, that is correct. And then next condition, that elements should have only one image in set B. So now we'll think one is related to A, one is related to B, one is related to A also, one is related to B also. So one is having two images, right? So one is having two images. So this is not a function. 2 is having one image, that is correct. 2 is having one image, 3 is also having image, that is correct. They are having single image, but 1 is having two images. So this is not a function, because the definition of function is every element of the set A should have one and only one image in the set B. So this is not a function. Now I'll consider another relation. We'll think, is it a function or not? So I'll consider now another relation from set A to set B. So it is having element, A is having element 1, 2, 3, B is having element A, B, C. And I'll consider 1 is related to B, 2 is related to B, 3 is also related to B. So this is a relation from set A to set B. Yes, this is the relation because it is subset of A cross B, because this is having element 1 comma B, 2 comma B and 3 comma B. And now we'll think this is a function or not. So what is definition of function? Every element in the set A should have one and only one image in the set B. 1 is having image, yes, that is correct. 2 is also having image, that is correct. 3 is also having image, that is also correct. So 1 is having image 1, B is image of 1, and then B is also image of 2, and 3 is also having image B, right? So B is image of 3 or 3 is having image B, right? So each and every element is having image, and that is having single image. They are having only one image, yes. All the element of the set A, they are having only one image, that is correct. They can have same images. All the elements of the set A should have same image in the set B, that is not a problem, but they should have only one image in the set B. So this is also a function. So hope you are all understanding the definition of function. What is that? Every element of set A should have only one image in the set B. And here also this is very important, how to find domain, range and codomain of a function. So see here first. So what I told about the domain is nothing but wherever arrow is going to start. Wherever arrow is going to start, that is we are going to call as a domain. And here think this relation in this function, all the elements of set A are going to map with the sum of the elements of the set B. Means all the elements, the arrows is starting with each and every element of the set A. So we can call the domain as 1, 2, 3. Domain of this function as 1, 2, 3. Domain of this function as what here? 1, 2, 3. And then I told you wherever arrow ends, that we are calling as range of the function. So wherever arrow ends with A, B, C. So wherever arrow ends, that is what range of the function or range of the relation. So range of the function here A, B, C, because our arrow ends with A, B, C. And codomain is always second set. Here also codomain is always second set. So set B is called as the codomain of the function. And now this is function, it's then fine. And this is also function because each and every element of the set A is having only one image in the set B. And now think, what is the domain here? Wherever arrow is going to start, that is what here domain, the set of all the elements which our arrow is going to start. So domain of this function is also what? 1, 2, 3. Domain of this function is also 1, 2, 3. And what is range here? Range is where our arrow ends. Our arrow ends with what here? A and B. Arrow ends with A and B. So therefore range of this function is what here? A, B. And domain can we call as domain as set A here? Yes, we can call set A as the domain here because each and every element of the set A is going to map with the sum of the elements of the set B. So therefore we can call set A is the domain of the function. And range is wherever arrow ends, or else set of image elements. So A and B are images of some elements of the set A. So therefore set of image elements A comma B. So that is range of a function. And set of all pre-images we can call as a domain of the function. And now this is not a function if it is a relation, and you know how to find its domain and range. And now this is also not a function. In case of relation, you know how to find its domain, range and codomain. And now this is a function, right? This is a function. So what is domain of this function here? The domain of this function is wherever arrow starts, or else the set of all pre-images. What are the pre-images here? 1, 2, 3 are the pre-images, or set of all elements where our arrow is going to start. Arrow is going to start with 1, 2, 3. So domain of this relation is 1, 2, 3. That is nothing but set A, right? And then what is range of the function here? The set of all image elements, or the set of all where our arrow ends. Okay, so where is our arrow ends here? Arrow is ends with B only. So therefore range is set containing an element B here. Okay, so what is codomain? Codomain is always second set. The codomain is always second set. Second set B is called as a codomain of the function. Hope you are all understanding this one. So if f is a function from set A to set B, that we are writing as f is a function from set A to set B, and read it as f is a function from set A to set B, or read it as f is a mapping from set A to set B. If f is a function from set A to set B, here always set A is always represents the domain, and B, this is always represents the codomain. Second set B, this is always represents the codomain. In terms of function only, this set A is always domain of the function, and set B is always the codomain of the function. And set of all image elements, we are going to call it as a range, and obviously range is subset of codomain, or sometimes range is also equals to codomain. Okay, so range is subset of codomain, and set of all image elements we are going to call as a range of the function. So hope you are all understand what is function and how to find its domain, codomain and range of a function. So now we'll consider another example. Now take these all relations and we'll think these relations are function or not. So what is the question here? Examine each of the following relations given below and state in each case giving reasons whether it is a function or not. So they have given three relations and we have to think these three relations are functions or not. So what is the definition of function? Every element in the set A should have one and only one image in the set B, or else you can call like this also. Every element in the domain should have one and only one image in the codomain. Every element in the domain has one and only one image in the codomain. So now we'll think the domain of this relation is having elements 2, 3, 4. All the elements should have image, and that too what here? Single image. And 2 is having image 1, 3 is also having image 1, 4 is having image 2. So each and every element of the domain is having image, and that too what here? One and only one image in the codomain. So this relation, is it a function? Yes, obviously this relation is a function, because f of 2 is having image 1, and then 3 is also having image 1, and then 4 is having image 2. Each and every element of the domain is having image, that too what here? Only one image in the codomain. So therefore this relation we can call it as a function. And now take the second example. Is this a function or not? Here take 2 is related to 2. 2 is also related to 4. See here, 2 is having image 2, 2 is having image 4. See here, each and every element of the domain should have only one image in the codomain, but 2 is having two images here, right? So 2 is having two images. 2 is having image 2 and 2 is also having image 4. 2 is having 2 images here. So therefore this is not a function. This one with arrow diagram I will consider. So this domain is having element 2, 3, 2 is having image 2 and 4. So if you are seeing the diverging rays from any element of the domain, so this type of relation is not a function. If you are seeing the convergent rays, you can call it as a function. But here if you are seeing the diverging rays from any one element of the domain, so this type of relation is not a function because 2 is having here 2 images. Okay, so this element should not repeat here. Okay, now take third example. Is it a function or not? We'll think. So here think relation is having element 1, 2, 2, 3, 3, 4, 4, 5, 5, 6 and 6, 7. So this is a relation from domain to codomain. So they have not mentioned from set A to set B. So each and every element in the domain should have one and only one image in the codomain. So 1 is having image, yes, 1 is having image 2 and 2 is having image 3 and then 3 is having image 4 and then 4 is having image 5 and then 5 is having image 6 and then 6 is having image 7. So each and every element of the domain is having single image in the codomain. So here domain is what here? The domain is having element 1, 2, 3, 4, 5, 6 and codomain is having elements 2, 3, 4, 5, 6, 7. So 1 related to 2, 2 related to 3, 3 related to 4, 4 related to 5, 5 related to 6, 6 related to 7. So this is a function from domain to codomain because each and every element of the domain is having only one image in the codomain. So this is a function, but this relation is not a function because 2 is having 2 images. So this type of relation we are not going to call as a function. Hope you are all understanding this one. I'll consider now next example. Let's take now next example. So what is that? Let n be the set of natural numbers and relation are defined on n such that the relation is defined set of all x comma y such that y is equals to 2x and x comma y is belongs to set of natural numbers. So we have to find here what is domain, codomain and range of the relation, and next question is this relation function? So what is the relation here? The relation is defined. What is the relation between x and y here? Y is equals to 2x. Now convert set builder form of this relation to roster form. So if y is equals to 2x, they have told x comma y is belongs to set of all natural numbers. So first x I will substitute, x is equals to 1. So I am getting y is equals to what here? 2. X is equals to 1, y equal to 2. X is equals to 2, what I am getting y? Y is 4. If x is equals to 3, what I am getting y? Y is 6. If x is equals to 4, I am getting y is equals to what here? 4 into 2, this is what here? 8. So up to that, if you put x is equals to n, you are going to get y is equals to 2 times of n. So these are the elements are coming under the relation. So what is relation we are getting in roster form? 1, 2, 2, 4, then 3, 6, 4, 8 and then this is continuous up to n number of elements. So this is a relation. And now what is its domain will think. So what is the domain? All first elements of the ordered pairs of the relation. The set of all first elements of the ordered pairs of the relation is called as a domain. Okay, so what are the first elements here? 1, 2, 3, 4 up to n number of elements, that is set of all natural numbers. So therefore 1, 2, 3 up to n numbers we are substituting. This is nothing but domain of this relation is set of all natural numbers. Okay, so whatever we are going to substitute, that is domain. Input means whatever we are going to substitute, whatever we are going to put as a input values, that we are calling as a domain. Means the set of all x values that represents the domain. So domain is set of all natural numbers. So what is range here? So whatever the output is coming, that is set of all y values. Okay, so here x is independent variable and y is dependent variable, and y is depends on x. Okay, so here the set of all y values we are going to call as a range. Okay, or else set of all outputs we can call as a range. Here a range, what we have got here, range here, see 2, 4, 6, 8, and this is what here, the twice of the natural number, or set of all even natural number. Okay, set of all even natural number. So what we got range here, set of even natural numbers, even natural numbers, set of all even natural numbers. And what is codomain? You know codomain. Codomain is always second set. So what is the second set? Relation is defined on the set n. Its meaning, relation is defined from set of natural numbers to set of all natural numbers. So therefore here codomain of this relation, codomain of this relation is set of all natural numbers. Is the next question here, is this relation is function? Yes, this relation is function. Yes, obviously this relation is function, because each and every element in the domain, they are having one and only one image in the codomain. So therefore this relation is a function. So if it is a function, means f is a function from set of natural numbers to set of all natural number. Therefore domain is set of all natural number, codomain is set of all natural number. The set of all image elements is called as the range of the function. Hope you are all understanding this one. With the help of graphical method also we can think whether the given curve is a function or not. If you know the graph of the particular curve, then we can think whether it is a function or not. So to determine whether the given curve is a function or not, we are going to consider vertical line test. Okay, so with the help of vertical line test, we can think the given function or the given curve is a function or not. Okay, so with the help of vertical line test. Okay, so I'll consider now first the famous U graph, that is what, upward parabola, that is the graph of y is equals to x square. Okay, so with the help of graphical method, so I am considering the graph as y is equals to x square. Now we'll think this is a function or not, y is equals to x square. So this is what here, upward parabola. And now take vertical line test for this. Now draw vertical line to this graph. If the vertical line intersect the given graph at only one point, then that time we can call the given curve is a function. If it cuts at the 2 points, then the given curve is not a function. So I'll consider now vertical line. Wherever you want, you can take vertical line test. Vertical line you draw on the graph, and it is going to intersect the given graph at only one point. And here also, you wherever you want you can draw, vertical line to the given graph. If it cuts at only one point, then that time this is a function. And now this cuts at only one point, therefore this is a function. So now I will consider another graph, that is right-handed parabola, that is the graph of y square is equals to x. The graph of y square is equals to x comes like this. Okay, so we'll take now vertical line test for this. Is it a function or not, we'll think. So I'll consider vertical line test for this. The vertical line cuts the given graph at 2 points. So therefore this is not a function. Means if y square is equals to x is there, y is what here, root x. Y is root x. If you substitute x is equals to 1, we are getting y as what here, root 1. That is y is plus or minus 1. 1 is having here 2 images. Okay, so 1 is having 2 images. 1 is having 2 images, 1 and minus 1. So therefore this is not a function. If you substitute x is equals to 4, you are getting y as what here, root 4. Means y is equals to plus or minus 2. So again 4 is also having 2 images. That is what, 2 and minus 2. Therefore 2 and minus 2. Therefore this is not a function, because if any one element in the domain is having 2 images, that time the given relation is not a function. So therefore this is not a function. And all the functions are acts like a machine. So whatever you are putting input, whatever you are giving input, and it is going to give only one output. I have considered the machine is a juicer. If I have given fruits for this, it is going to give some output, that is what we are going to get as a juice. If you given mango fruits to juicer, you are going to get mango juice. If you are giving orange juice to juicer, you are going to get orange juice. Okay, at a time you are not getting two outputs. If you are putting mango fruits, you are getting mango juice. If you are putting orange fruit, you are going to get orange juice. If you are putting mango, not going to get mango juice as well as orange juice, right? So machine is giving only one output, depends upon the values of the particular domain values, particular inputs. Okay, for this juicer I have to put only fruits, I should not put woods, stones, like that. Okay, so this domain should be defined, then only this function exists. Okay, so now, and here one is giving two images, means one is going to give two outputs, right? So one is giving two outputs, 1 and -1, and 4 is also giving two outputs. 4 is also giving two outputs as 2 and -2. So this is also not a function. Therefore, y square is equals to x. This is not a function. Now I will consider the famous V graph, that is modulus function. And now we'll take vertical line test for this, and now think y is equals to mod x. Is it a function or not? Okay, so y is equals to mod x. This is, you have learned in the first year itself. This is a famous V graph. And now we'll take vertical line test for this. Vertical line test for this. The vertical line cuts at only one point. So therefore this is a function, and y square is equals to x. This is not a function because the vertical line intersect the given graph at 2 points, and this is also function because the vertical line intersect the given graph at only 1 point. And now we'll take few more examples. Based on that you will understand. Now I'll consider the graph of x cube. Okay, cubic function graph I am going to consider. Now the graph is y is equals to what here? X cube. Cubic function graph I am going to consider. So y is equals to x cube. This already from the first year. So this is the graph of y is equals to x cube. And now do vertical line test for this, and now draw vertical line for this, and it is going to cut and it is going to intersect at only 1 point. Wherever you draw vertical line to the given graph, it is going to intersect at only 1 point. So therefore this is a function. I am going to consider now another function, that is y is equals to 1 by x. This is a rational function. So now we'll think whether it is a function or not. Y is equals to 1 by x, and this graph also from the first year itself. The graph of this function will comes like this. This is the graph of y is equals to 1 by x. Okay, so this is the graph of y is equals to 1 by x, and now we'll take vertical line test for this, and now we'll decide whether it is a function or not. Now I am going to draw vertical line to this graph, and it is going to intersect at only 1 point. It is going to intersect at only 1 point. Therefore y is equals to 1 by x. This is a function. Depends upon the graph, means if you know the graph of the given function particularly, and then you can decide whether it is a function or not. Okay, hope you are all understanding. This is the homework question for you people. So I have given 4 relations, and you should recognize which of these following relations are functions and which of the following relations are not functions, and do this one and send me this answer through WhatsApp. And whatever the doubts you are having in this particular class also, you can call me or you can message me at any time. With this I will end my today's session. Thank you.